All right, let's just jump right into it. Welcome to this explainer on the absolutely wild frontier of energy storage. We are going way, way beyond your standard AA batteries today. I mean, when most of us hear the word battery, we usually picture that little cylinder we shove into a TV remote, right? Or maybe you think back to a middle school science fair and the classic potato battery. No, fun little side note there, the potato is actually just the electrolyte. It's the metals you stick into it that are doing the real work. Anyway, what happens when we need to power, say, entire cities and not just a single light bulb? That's what we're exploring today, the absolute cutting edge of how we store power.
And to guide us, we've got an unofficial motto for this journey. Electrical engineering, where almost anything could be a battery if you use it wrong enough. I just love that. It perfectly captures exactly what we're about to look at. You're going to see how brilliant minds are taking this incredibly playful idea to heart. They're looking at the everyday world around them and turning the most unexpected, mundane things into literal power grids.
So I want you to completely throw out your preconceived notions of what a battery even looks like. Seriously, what if the literal body of your car was its battery? Or what if the concrete foundation of your home could store an entire day's worth of solar energy? What if a giant pile of rust, yes, rust, could keep a city's lights on for 4 days straight? We're talking about mind-blowing, very real technologies that stretch the definition of a battery from a tiny chemical cylinder to a spinning wheel, a deep, dark mine shaft, or a massive vat of liquid salt. We're looking at compressed gas, biology, and even nuclear decay. We are literally redefining power.
Now, before we get too crazy, we really have to make an important distinction right up front. Don't get me wrong here. Lithium-ion is a miracle technology. It's incredibly energy dense, it's super fast, and it's absolutely perfect for things that need to be light and mobile. Think your phone or an electric vehicle. But for the massive power grid, well, we need completely different tools. See, lithium-ion gets really expensive at grid scale, and its performance drops after lots of charging cycles. When you're running a whole grid, you don't care if the battery is lightweight. You need it to be cheap, you need it to be massive, and you need it to last for days.
And why exactly do we need this massive, long-duration storage? Well, it all comes down to a fantastic and frankly somewhat intimidating German word, Dunkelflaute. It roughly translates to the dark doldrums. Just picture this, ominous, imposing block of time right in the dead of winter, where the sun just isn't shining for the solar panels. And there's absolutely zero wind blowing for the turbines, sometimes for days on end. When the weather flat out refuses to cooperate, we desperately need long-duration storage that can step in and keep the lights on without relying on real-time weather.
But hey, it's not always about these long, slow energy drains. Sometimes it's about massive instant spikes. Take the UK, for example. What on earth does the British TV schedule have to do with the power grid? Well, it's a very real phenomenon known as the TV pickup. It's inherently hilarious, but it is incredibly serious for engineers. Basically, when everyone in Britain turns on their electric kettle at the exact same moment, usually during a commercial break of a massive football match or a popular soap opera, the grid gets hit with a sudden, massive demand for power. If the grid can't supply that sudden burst of electricity, boom, blackout. So, to catch that massive surge, we don't use chemistry at all. We use physics. Enter mechanical batteries, specifically flywheels. Think of a flywheel as a massive carbon fiber spinning top. To keep them from losing energy to friction, these modern flywheels are actually suspended in mid-air using magnetic bearings, and they're sealed inside a vacuum chamber to completely remove air resistance. These things spin at terrifying speeds. We're talking up to 50,000 revolutions per minute. When the grid needs a sudden jolt of power to boil a million kettles at once, these spinning tops release all that kinetic energy in milliseconds. It is literally motion acting as a battery. Okay, let's move to our next mind-bending concept. And we're going to start with this massive number, 500,000. That's roughly the number of abandoned coal mines scattered across the United States. Now, for decades, people have just viewed these as symbols of industrial decline or, environmental hazards. But today, engineers are peering down into these deep, dark vertical shafts and seeing something entirely different. They see giant underground water batteries. This is gravitational energy storage, specifically pumped hydro. And the concept is beautifully simple. When electricity is cheap and abundant, like on a really sunny afternoon, you use that excess power to pump water from the bottom of the mine shaft all the way up to a reservoir at the top. You are literally storing energy as gravity. Then, when the sun goes down and everyone turns their lights on, you just let that water drop back down the shaft, which spins a turbine along the way and generates electricity. We are harnessing gravity itself for massive grid-scale energy. And because it's underground, we aren't destroying surface landscapes or building huge new dams.
Which brings us perfectly to our next category, thermal storage. Instead of storing energy as motion or gravity, we're just storing it as pure heat. Take a look at this. This is an aerial view of the Crescent Dunes solar plant. All those mirrors are reflecting sunlight onto a central tower to heat up millions of gallons of liquid nitrate salt. This salt gets stored in these massive, highly insulated tanks. It basically acts as a giant thermal battery, holding on to that intense heat so incredibly well that it can be used to generate steam and spin turbines long after the sun has actually set.
The real secret to why this works so flawlessly is this number right here, 570 degrees Celsius. This liquid solar salt gets unimaginably hot. But here is the magic trick. Unlike water, which boils and turns into high-pressure steam at just 100 degrees, this salt mixture stays a stable liquid even at these extreme temperatures. And because it doesn't boil, the storage tanks don't need to be highly pressurized. That makes the whole system incredibly safe, super cost-effective, and capable of storing just immense amounts of energy as heat.
But get this, you don't even need fancy liquid salt to store heat. Over in a town in Finland, engineers built a massive insulated silo. We're talking 13 meters tall. And they filled it with 2,000 tons of crushed sand and soapstone. And here's the absolute kicker. That soapstone is a recycled waste byproduct from local ceramics manufacturing. They use excess renewable electricity to heat this sand up to around 500 degrees Celsius. Sand can hold on to heat for months. So all through the freezing, bitter Finnish winter, this literal industrial waste warms the town's entire district heating network. It's just brilliant.
Now, let's look at what might be one of the most poetically elegant energy storage technologies ever conceived. I mean, using rust as a battery sounds completely absurd, right? At least until you dig into the chemistry. Form Energy's iron-air battery is wildly simple. Humans have known for millennia that iron, water, and oxygen create rust, but that reaction also releases energy. When this battery discharges, it literally breathes in oxygen from the air, the iron inside rusts, and it releases electrons to the grid. To charge it back up, you just feed it electricity, which throws the reaction into reverse, expels the oxygen back out, and turns the rust back into solid iron. It is reversible rusting. And the numbers behind this rusting battery are just staggering. They provide 100 hours of continuous storage at roughly 1/10 the cost of lithium-ion. That's 4 full days of backup power. And honestly, my absolute favorite part? These washing machine-sized iron batteries are being manufactured right now in a massive former steel mill in West Virginia. The Rust Belt is literally manufacturing rust batteries to solve that Dunkelflaute problem we talked about. It is just such a perfect, poetic solution for revitalizing post-industrial communities while securing our energy future.
Okay, let's shift gears to our final category today and see how all this builds into something called structural power. But first, a quick definition. What is a supercapacitor? Well, unlike a standard battery that uses slow chemical reactions, a supercapacitor stores energy using a static electrical charge across conductive plates. Think of it kind of like the static cling you get from rubbing a balloon on your hair, but on a massive, highly engineered scale. They charge and discharge instantly. In fact, fun story, before engineers started putting these into buildings, supercapacitors made some wild headlines in professional cycling. Riders were actually caught using them, hidden completely inside their bike frames as structural batteries, to cheat. So take that hidden supercapacitor concept and mix it with the most widely used building material on planet Earth. MIT researchers recently realized they can mix standard cement and water with a highly conductive soot called carbon black. Amazingly, this is the exact same ancient pigment used to write the Dead Sea Scrolls. As the cement cures, the water gets absorbed, leaving behind this wildly complex branching network of microscopic tunnels. The carbon black fills those tiny tunnels, creating a massive wire-like internal surface area within solid concrete. They essentially figured out how to turn a block of concrete into a giant supercapacitor.
So what does that actually mean for us practically? Well, just 45 cubic meters of this carbon-laced concrete could store 10 kilowatt-hours of energy. To put that into perspective, 45 cubic meters is roughly the size of the foundation of an average house, meaning the literal concrete slab your house sits on could soon store a full day's worth of the solar power generated by your roof. No massive battery packs taking up space in your garage, because the actual physical structure of the building is the battery.
Which brings us to our final, somewhat provocative thought. We've seen energy stored as motion in high-speed spinning flywheels, as gravity deep in abandoned coal mines, as intense heat in vats of salt and silos of recycled waste sand, as reversible rust, literally breathing oxygen, and even as static charge locked inside the very concrete we build our cities with. The takeaway here is clear. Energy can be stored as chemistry, heat, motion, gravity, pressure, biology, or the very structure of the buildings and vehicles around us.
Remember our motto, a great electrical engineer sees batteries everywhere. So look around you today. Keep your mind open. What completely ordinary thing will we use wrong enough to turn into a battery next? Thank you so much for joining me for this explainer. I'll catch you next time.